I'm being asked to show that the sum of two odd numbers is always an even number. Now, it's quite tempting to pick two odd numbers, for example, let's say 3 and 5, and show that they add up to make an even number, 8. But this only shows that it's true for these two particular odd numbers. I want to show that this is always true, so I'm going to do this algebraically. We can write any number as n. To make this an even number, it must be a multiple of 2, so it will be 2n. So this is now an even number. To make it an odd number, we would add 1 onto it. So any odd number is 2n add 1. Now I want the sum of two different odd numbers, so I'm going to do the same thing but with a different letter. So m is any number, 2m is an even number, 2m add 1 is now an odd number. I want to show that the sum of these is even, so let's add them up and see what happens. I get 2n plus 2m plus 1 plus another one, so that's 2n plus 2m plus 2. Now I want to show that this number here is definitely even, and the way I do that is by taking out a factor of 2. So if I take a factor of 2, I'm left with n plus m plus 1. Now because this number here is a multiple of 2, then it must be even. So I've shown that the sum of two odd numbers, here and here, is definitely even. So I write my concluding statement, 2n plus m plus 1 is a multiple of 2, therefore it is always even. This working out and this statement is my final answer. Here's one for you to try now. Press pause and have a go. When you're ready, press play. So to answer this, my first even number is going to be 2n, and my second even number is 2m. I want the sum of these, so I add them together. That gives me 2n plus m if I factorise. Now I know that this is always even because it's a multiple of 2, so I write that as my final statement. So this whole thing is the final answer. Now in this question, I'm asked to show that the difference of the squares of two odd numbers is always even. So I need my two odd numbers again. So my first odd number was 2n plus 1, and my second odd number was 2m plus 1. Now I need the difference, that means take away, of the squares. So each of these needs to be squared. And I want to prove that this is always even. So first of all, I'm going to multiply out this bracket. So I've got 2n plus 1 squared means I need to multiply it by itself. So that gives me 4n squared plus 4n plus 1. I also need to multiply out this bracket. So that's 2m plus 1 squared, so that's multiplied by itself. And that gives me 4m squared plus 4m plus 1. So I now have all of this. That's 4n squared plus 4n plus 1. Take away all of this. That's 4m squared plus 4m plus 1. So I've got 4n squared plus 4n plus 1, and everything inside this bracket gets multiplied by minus 1. So I've got minus 4m squared minus 4m minus 1. Now simplifying this gives me 4n squared plus 4n minus 4m squared minus 4m, because plus 1 and minus 1 goes. Now I want to prove that this is always even. To do that, I factorise and I take out a factor of 2. So if I take out a factor of 2, I get 2n squared plus 2n minus 2m squared minus 2m. This must be even because it's a multiple of 2. So this is my concluding statement. All of this makes up my final proof. Here's one for you to try now. Press pause and have a go. When you're ready, press play. Here's the algebraic proof for that one. I'm now being asked to show that the sum of two consecutive odd numbers is always a multiple of 4. Before we do this, we need to understand what consecutive means. So to give you an example, 23, 24, 25, 26 and 27 are consecutive numbers. It means numbers that come one after the other. Consecutive odd numbers would be 23, 25 and 27. You can see that to get from one odd number to the next odd number, we add on 2, and these two odd numbers are consecutive. So I'm going to start with an odd number, remember that's 2n plus 1. To get the next odd number, I add on 2, so that's 2n plus 1 plus 2, which is plus 3. I want the sum of these, so I'm going to add them together. So adding and simplifying, I get 2n plus 2n, so that's 4n, plus 1 plus 3, so that's plus 4. I want to show that this is a multiple of 4, and I can do that by taking out a factor of 4. So if I factorise, I get 4n plus 1. Now this number must be a multiple of 4, so I've proved what I've been asked to show. So this is my concluding statement, and I've now finished my proof. Here's one for you to try. Press pause and have a go. When you're ready, press play. Here's what the finished proof looks like. Here's another one for you to try. Press pause and have a go. When you're ready, press play. This is what your proof should look like. I've squared this bracket here and squared this one here. I've then subtracted those, which gives me this, which simplifies to 24n. Now the important step is that you can take a factor of 8 out to give you 8 times 3n. And because you can take out a factor of 8, we know that this is a multiple of 8. Here's another question for you to try. This time you're trying to prove that the sum of the squares of any two consecutive odd numbers cannot be a multiple of 4. Press pause and have a go. When you're ready, press play. So here's the beginning of the proof. I've got my two consecutive odd numbers, I've squared them, and I've found the sum by adding them. I get this, which simplifies to this. Now, if this is a multiple of 4, then I can take out a factor of 4. It works with the 8 and it works with the 16, but 4 isn't a factor of 10. So this number cannot be a multiple of 4. I write a concluding statement to explain this, and this completes my proof.